process that disagree with each other, right? And so we would do the work in visual inspection. We will, take, say, a plastic pot and show it to one inspector, and the inspector, sometimes very opinionated, they'll go, clearly that's a defect, this scratch, unacceptable, gotta reject this pot. Take the same pot to a different inspector, different, very opinionated, clearly this scratch is small, it's fine, don't throw it away, because and then sometimes you take the same plastic pot, show it to the same inspector in the afternoon as opposed to the morning, and very opinionated go, in the morning they say, clearly it's okay, in the afternoon, equally confident, clearly this is a defect. And so what is the AI team supposed to do if sometimes even one person doesn't agree with himself or herself in the span of a day? So I think these are the types of very practical, very messy data problems that my teams wrestle with. In the case of large consumer internet companies, we have 1 billion users, we have a lot of data, you don't worry about it, just take the average, it kind of works. But in the case of other industry settings, we don't have big data, if it's a small data, very small data sets, maybe around 100 defective parts, or 100 examples of a defect. If you have only 100 examples, these little labeling errors, if 10 of your 100 labels are wrong, that actually is 10% of your data set, has a big impact. So how do you clean this up? What are you supposed to do? This is an example of the types of things that my teams, this is a landing AI example, are wrestling with to deal with small data, which comes up all the time once you're outside consuming internet.
Yeah, that's fascinating. So then you invest more effort and time in thinking about the actual labeling process. What are the labels? How are disagreements resolved, and all those kinds of pragmatic real world problems. That's a fascinating space.
I find that actually when I'm teaching at Stanford, I increasingly encourage students at Stanford to try to find their own project for the in-term project. Rather than just downloading someone else's nicely clean data set, it's actually much harder for you to go and define your own problem, find your own data set, rather than go to one of the several good websites, very good websites, with clean scoped data sets that you can just work on.
You're now running 3 efforts: the AI Fund, Landing AI, and Deep Learning.ai. As you've said, the AI Fund is involved in creating new companies from scratch. Landing AI is involved in helping already established companies do AI, and Deep Learning AI is for education of everyone else, or of individuals interested of getting into the field and excelling in it. So let's perhaps talk about each of these areas. First, Deep Learning.ai. Basic question, how does a person interested in deep learning get started in the field?
Deep Learning.ai is working to create courses to help people break into AI. So my machine learning course that I taught through Stanford is one of the most popular courses on Coursera.
To this day, it's probably one of the courses, sort of, if I ask somebody, how did you get into machine learning, or how did you fall in love with machine learning, or would get you interested, it always goes back to Andrew Ng at some point. So the amount of people you've influenced is ridiculous. So for that, I'm sure I speak for a lot of people, say big thank you.
No, thank you. I was once reading a news article on, I think it was Tech Review, and I'm going to mess up the statistic, but I remember reading an article that said something like 1/3 of our programmers are self-taught. I may have the number 1/3 wrong, it's 2/3. But when I read that article, I thought, this doesn't make sense. Everyone is self-taught. So, because you teach yourself, I don't teach people. I just
That's well put. So how does one get started in deep learning, and where does Deep Learning.ai fit into that?
So the deep learning specialization offered by Deep Learning.ai is I think it was Coursera's top specialization. It might still be. So it's a very popular way for people to take that specialization to learn about everything from neural networks to how to tune a neural network, to what is a ConvNet, to what is a RNN or sequence model, or what is an attention model. And so the deep learning specialization steps everyone through those algorithms so you deeply understand it and can implement it and use it for whatever.
From the very beginning. So what would you say are the prerequisites for somebody to take the deep learning specialization in terms of maybe math or programming background?
Yeah, you need to understand basic programming since there are programming exercises in Python. And the math prereq is quite basic, so no calculus is needed. If you know calculus, is great, you get better intuitions, but deliberately try to teach that specialization without requiring calculus. So I think high school math would be sufficient. If you know how to multiply two matrices, I think that's great.
So a little basic linear algebra. That's great.
Basic linear algebra, even very basic linear algebra in some programming. I think that people that have done the machine learning course will find the deep learning specialization a bit easier. But it's also possible to jump into the deep learning specialization directly. But it'll be a little bit harder since we tend to go over faster concepts like how does gradient descent work and what is the objective function, which is covered more slowly in the machine learning course.
Could you briefly mention some of the key concepts in deep learning that students should learn that you envision them learning in the first few months, in the first year or so?
So if you take the deep learning specialization, you learn the foundations of what is a neural network. How do you build up a neural network from a single logistic unit to a stack of layers to different activation functions, even how to train the neural networks. One thing I'm very proud of in that specialization is we go through a lot of practical know-how of how to actually make these things work. So what are the differences between different optimization algorithms? What do you do if the algorithm overfits? Or how do you tell if the algorithm is overfitting? When do you collect more data? When should you not bother to collect more data? I find that even today, unfortunately, there are engineers that will spend 6 months trying to pursue a particular direction, such as collect more data, because we heard more data is valuable. But sometimes you could run some tests and could have figured out 6 months earlier that for this particular problem, collecting more data isn't going to cut it. So just don't spend 6 months collecting more data. Spend your time modifying the architecture or trying something else. So go through a lot of the practical know-how so that when you take the deep learning specialization, you have those skills to be very efficient in how you build these networks.
So dive right in to play with the network, to train it, to do the inference on a particular data set, to build an intuition about it without building it up too big to where you spend, like you said, 6 months learning, building up your big project without building an intuition of a small aspect of the data that could already tell you everything you need to know about that data.
Yes, and also the systematic frameworks of thinking for how to go about building practical machine learning. Maybe to make an analogy, when we learn to code, we have to learn the syntax of some programming language, right? Be it Python or C++ or Octave or whatever. But the equally important, or maybe even more important part of coding is to understand how to string together these lines of code into coherent things. So, when should you put something in the function column? When should you not? How do you think about abstraction? So those frameworks are what makes a programmer efficient, even when they're understanding the syntax. I remember when I was an undergrad at Carnegie Mellon, one of my friends would debug their code by first trying to compile it, and then it was C++ code. And then every line that was syntax error, they want to get rid of syntax errors as quickly as possible. So how do you do that? Well, they would delete every single line of code with a syntax error. So really efficient for getting rid of syntax errors, but horrible debugging sometimes. So I think, so we learn how to do that. And I think in machine learning, the way you debug a machine learning program is very different than the way you do binary search or whatever. Use a debugger, trace through the code in traditional software engineering. So there's an evolving discipline, but I find that the people that are really good at debugging machine learning algorithms are easily 10x, maybe 100x faster at getting something to work. So
And the basic process of debugging is, the bug in this case, why isn't this thing learning, improving, sort of going into the questions of overfitting and all those kinds of things. That's the logical space that the debugging is happening in.
the often question is, why doesn't it work yet? Or can I expect it to eventually work? And what are the things I could try? Change the architecture, more data, more regularization, different optimization algorithm, different types of data. So to answer those questions systematically, so that you don't so you don't spend 6 months heading down the blind alley before someone comes and says, why did you spend 6 months doing this?
What concepts in deep learning do you think students struggle the most with? Or sort of is the biggest challenge for them once to get over that hill? It hooks them and it inspires them and they really get it.
similar to learning mathematics, I think one of the challenges of deep learning is that there are a lot of concepts that build on top of each other. Um, if you ask me what's hard about mathematics, I have a hard time pinpointing one thing. Is it addition, subtraction? Is it carry? Is it multiplication? There's just a lot of stuff. I think one of the challenges of learning math and of learning certain technical fields is that there are a lot of concepts, and if you miss the concept, then you're kind of missing the prerequisite for something that comes later.